Well, then, thank you for joining here this actually very last call, taking your time here, very last call in a 5-day event. Thank you, Stefan, for giving us the opportunity to present here. So welcome, everybody. My name is Christopher Anhalt, currently working as Vice President Product Marketing at Softing Industrial, already with the company since about 10 years, in this role maybe since 3 or 4 years. Okay, OPCUA, Information Model Management and Unified Namespaces. It's actually the first time Softing presents about this topic, the first time I present about the topic. So let me begin with a short explanation where we are coming from and why do we start talking about this and what is our vantage point. So as most of you know, Softing Industrial, specialist for industrial communication. We manufacture connectivity products which are used inside automation networks or for OT/IT integration. And we have seen in recent years, let's say maybe 1 or 2 years, that our products for OT/IT integration are increasingly being used in a different solution context with different challenges, which relates now mostly to the most innovative projects, of course. But we see clearly a shift here. The focus is no longer on southbound integration with OT devices, but with what we like to call northbound integration, the IT side in unified namespaces. And this has triggered here, let's say, work on that topic and what I'm going to present today. So what did I bring here? Now, if I manage to switch to next slide, that would be even better. This is working too, great. So I brought one slide, let's say, to rephrase the topic for today. What are we actually trying to answer here in this presentation? And then the biggest part, as you may have read in the agenda, I will report on not 2 actually, a certain agenda, but I decided to add a 3rd one with some information. So I will report on some project examples, as said, how our products are being used in a solution context that includes here now so-called unified namespaces, a short summary, and I will finish with a Softing reference architecture proposal based on the lessons learned here in these projects. I'm presenting this. I should add that the presentation, I created this presentation together with Soren Topan, a colleague of mine here, CTO in our R&D location in Cluj, who did, let's say, the real technical work behind of what I'm talking about today. So, as said, let me try to rephrase the topic for today, and I spoke about a changed solution context. To summarize this changed context, it's characterized by a central platform and a central data repository customers want to work with. So it's no longer a solution just for one production site. Customers are looking, of course, now since quite a while at central platforms, IoT applications they want to roll out across multiple sites. And in order to do so, there is like a general understanding, a general basic requirement. We need a central data repository which may include OT data only, but typically it includes more than OT data. And this is relevant. It includes semantic information, which enrich here the OT data. And this central repository, of course, helping IoT application development, scalability, and so on. Now, one of my key messages is here in this presentation, and I mentioned this already on this very first slide, organizational boundary conditions are critical. Yeah, we learned that already earlier with the transition to solution architecture as a central platform, what is managed centrally, what is managed locally by shop floor people. So we see here that organizational boundary conditions play a central role. Many customers we talk to, we are here the OPCUA specialist, of course, so this is our perspective. Many customers we talked to decided to use OPCUA, but still the technology know-how remains limited, in particular within IT. And by IT, I mean now, let's say, a team that may develop IoT applications or maybe data scientists. Typically, there you cannot assume that these that these people have OPCUA technology know-how. And this is a very relevant factor which needs to be taken into account when designing solution architectures. So what we are looking at is now how can these solution architectures be designed, OPC foundation models and unified namespaces, creating a central data repository that match organizational boundary conditions. And I begin with a first project example, the one where we learned the most, and where I want to spend the most time, a few minutes here in this presentation. As not typical for Softing, we didn't only pitch a product, so to say, but we were also engaged in a larger consulting project to provide in-depth consulting regarding the target architecture. So this is here a process industry example. Global company, more than 200 production sites. Typical case, the idea is to develop multiple IoT applications. In that case, the customer did choose the AWS cloud platform to do so, and the customer clearly decided on OPCUA as interoperability standard for OT-IT integration. Now, what we learned actually, and that was, so to say here, the new thing. Yes, there is a central organization that wants to work here now with the solution, but this is split between OT experts, people managing OPCUA information models, deciding how to design them, rolling them out, central governments for information models across all 200 production sites. But this team is clearly separate from separate teams, or maybe even multiple teams, people who work actually with the data collected. Yeah, IT people, a data scientist. So data scientists confronted with the task, hey, check why is the production site A, very similar machinery and process, have 30% more defects than site B, looks at it, hey, what data is available from the respective site? Where can I start digging deeper? What can I do? This person typically doesn't have OPC UA know-how, and the solution has to match that skill profile. Another boundary condition, no vendor lock-in on edge level. So yes, cloud is given, as in most projects we see, but again, typical in many projects, the customer would like to limit or even eliminate vendor lock-in with a specific cloud platform on edge. A bit more on technical level, so I already mentioned central governments for OPC information models. So models change, need to be updated, extended. For that, central governments is needed. It was clear that maybe as opposed to a very early idea to map OT data into information models enriched with semantic information on cloud level, this should be done on edge level, as close to the data source as possible. It's process industry. The customer decided to comply with NAMU open architecture, at least in many aspects. And there's also requirement, maybe detail here, that edge computing should be possible also when a cloud connection is interrupted or not there. So we started the discussion here with an initial architecture proposal, which is outlined here on the right-hand side. So what are maybe some interesting elements? There is an OPCUA aggregation server per site, collecting data from multiple OPCUA gateways, data sources. Yeah, it's another boundary condition, so to say, organizational in nature, that in this project, the company decided to leave it up to the individual site to decide on that gateway component, here shown here as a gray box production asset level. So that was not for technical reasons, but organizational reasons. Yeah, don't interfere, let them choose, give us any OPC interface, and we'll work from there. Another interesting aspect, the customer decided to use the UA cloud library here based on the initiative here, OPC Foundation, Microsoft. Also involved deploying this on AWS, interestingly. And we learned here that while Softing, so what is maybe here blue is a sort of Softing contribution, Softing could provide a standard product for server aggregation and information model management. Some critical components you could summarize as semantic extraction, and then how to store and work with semantic information on cloud level to build a data lake were still missing. And as I said, driven by organizational boundary conditions. Now I added this slide here, a very technical slide, maybe even a bit too small to read. and of course now a slide detailed architecture which deserves its own presentation or even a full day workshop to discuss it in detail. So this was the more detailed architecture proposal, maybe just some key elements here. You have that aggregation server at the bottom. The customer actually decided to skip the AWS IoT Sidewise connector, integrate semantic extraction with cloud connectivity in a potentially custom development for a cloud connector. The customer decided to use, this is critical here regarding the organizational aspects, MQTT and just standard JSON encoding to create unified namespace. This matches the skill set of the people working then with a unified namespace or a central data lake. And this architecture proposes a component shown here at the top here. Maybe you can read it, IM UNS mapper. So again, a component which doesn't exist as a standard product to map an information model to the unified namespace and to handle metadata to work with then also on edge level, but which has to be managed or the customer wants to manage on cloud level, like what is the payload, what is the sampling rate, and things like that. So this is, of course, just now a high-level overview. I tried to mention some aspects here, but just to give you an idea about the solution architecture and some detail maybe here, how this could work out. It's not exactly what the customer is now using in production. I may ask for your understanding. I can provide the customer name and more details here. And many elements are being used, like the cloud library actually running on-prem, an OPCUA aggregation server. Some other elements are changed. If you're really interested, contact us, sign an NDA, and we could talk more. Second example, when did I start now, by the way? We somehow didn't follow the schedule. I think I'm now like 10, 12 minutes into my talk, just that I try to stay within the 20-minute limit, more or less. The second and the third example, I now plan to keep that a bit shorter. Both are younger products, more recent, and still a pre-sale phase, so many things are still under discussion and to be negotiated. This is now an example in the food and beverage vertical industry. Again, a big company. In this case, the customer decided to work with, or had chosen already before, Microsoft Azure as the central cloud platform. Like the first example, the customer decided on OPCA as interoperability standard for OT/IT integration. So there is a clear need to, let's say, solve data integration once, that it works for multiple applications. There is a history in the project, as probably in many projects, that you start with kind of silos or individual connectivity solutions for individual applications. So this is a clear goal here to sort out connectivity once for a broad range of IoT applications. It needs to cover old machines and new machines. Maybe here is a more clear requirement that also on-prem applications need to be fed with data, need to run not only the central platform level. And again, and that is similar to the first example here and the repeating, let's say, situation here, personal developing IoT applications typically don't have OPCA knowledge, and the architecture needs to meet that boundary condition. So brownfield is heterogeneous. Siemens, Rockwell, Mitsubishi, depending on the production side, preferences for different vendors. Another similarity, it became clear that the semantic information, OPCA information models need to be applied as close as possible, mapping into these models as close as possible to the data source. And in that case, that's interesting, the customer decided to work with Weihenstephan standards, which is actually the companion spec we Softing have the most discussions about currently. So this is certainly not the only customer. We have a few projects, not many, but a few, where we discuss now these innovative solutions, food and beverage, where the customer wants to deploy companion specs according to the Weihenstephan standards. And again, here, a high-level overview. So deploying Weihenstephan information models with an aggregation server on edge level By edge, we mean it's on-prem, but it can be managed centrally as opposed to a production asset level. Again, here, for the time being, a preference for MQTT and standard JSON to transport here data between the aggregation server, the information model, and unified namespace. Actually, this need to create a unified namespace is having an implementation on-prem, cloud independent, and in the cloud. And here, a customer clearly choosing ISA 95 for equipment hierarchy or to structure the unified namespace, which is not an exception. We see that in most cases. Some questions are open. How to handle semantic extraction exactly. Is one aggregation server level enough, or are two needed? Maybe other information models. So I said it's an early project, but quite a few similarities, including the organizational topic. Example number 3. Strictly speaking, and I will also keep that relatively short, strictly speaking, it's covering only 50% of my topic here today. So this is not a project where we're discussing actually unified namespace, but only the other 50%, how to apply now information models, OPCUA information models, to integrate OT data into an IoT solution. In that case, I can mention the customer. I'm glad here that we added Vika. When I submitted the abstract, that wasn't so clear, and we could take quite a few steps here to prepare also Aachen affair. So I'm glad I could include this here and mention Vika. So Vika instrumentation, global company here, and in this project, a focus on certain industries to add connectivity according to actually the Namur open architecture to integrate here sensor data into now innovative solution scenarios. Yeah, M&O sensors, LoRaWAN network, and it's not only Namur, or well, not only Namur includes also now the PADIM and companion spec, which shall be applied here. And the customer, you see here a solution diagram coming from the customer, LoRaWAN, and we are glad we could help here with the edge aggregator product, which is now taking data. Interestingly, the data source is now connected via MQTT. We map it into the PADIM information model and make it available here to applications. As said, this is not a full solution in production with unified namespace, so there are options. It was interesting for me. I used this as a trigger to discuss with a few Namur representatives as Aachener how Namur is seeing the topic of unified namespaces, how to design here solution architectures. My understanding, I'm not a Namur expert, I have to admit, not really close, but the preliminary feedback I got, my understanding out of scope for Namur now to cover here questions of unified namespaces or how to design architectures on central platform level. This just as a remark aside. Okay, so bottom line here from a software perspective, if you allow me this one statement here, in a nutshell, you can consider the topic of how to map brownfield into OPCUA information models in innovative projects. Please consider it as solved. We have an offer. Other companies, of course, offer similar products. So what is the summary here? As far as we see, many customers opt for OPCUA as the standard to handle OT-IT integration in the new innovative IoT solutions. PubSub messaging is a given practically in all the situations, and in practically all the situations, all the projects we see, the customer prefers ISA 95 or decides to use ISA 95 for namespace structuring. Organizational boundary conditions matter. I think I repeated that now already multiple times. It's key. And regarding UNS, Unified Namespace implementations, as far as we see, when you look at the details, actually, the market isn't there that standardized reference architectures exist. As far as we could see, there's always a need to discuss based on individual requirement solutions, a solution architecture to sort out here quite a few and relevant technical details. Yeah, like how do you manage which data is published, the sampling rate, which topics shall be chosen to publish, how to format the published data, and so on. So I think the devil is here in the detail. And while some standard products exist, for us, a lesson learned here when it comes to realizing these innovative solutions, quite a few other components, it remains a bit unclear at this point. No standardized reference architectures how to do it. I finished my presentation here with this final slide, again, a technical slide beyond this talk, of course, to discuss it in detail. Of course, we also understand Softing. We are a small company compared to quite a few other companies proposing architecture, reference architectures. So this is to be understood as a proposal. Yeah, maybe just to pick one or two interesting elements. So we definitely see a potential to apply AI here in the mapping component at the top. Yeah, this may relate to the OPC Foundation Working Group for AI, which has been started more recently. Of course, you have a server aggregation component at the bottom. This is what Softing can contribute right now, clearly. For Softing, it remains an open question. We currently investigate whether there's room for us to expand our standard product portfolio here. Let's say, in this northbound direction, but this is undecided, something we currently discuss. So I guess 20 minutes are over, or maybe already now 22. As said, I created this presentation here with Sorin. You see the picture here at the right-hand side. And if you have any further questions, would like to discuss these solution architectures in detail, we would be glad to hear from you. So thanks again, and Stefan, back to you.